final exam. This is huge. It's a very important topic for Calc 1. So you will have an example like this or a question like this. This is important, but not as big as this. The factor and the remainder theorem. Both are important. Equations. Log equations, exponential, rational, trig. Huge topic. Very important. Simplifying by factoring. Huge. Very important. Graphing, finding asymptotes, and minimax of a function. This is very important in Calc 1. It will be done again in Calc 1. I consider it an important topic, but I don't consider it a huge topic. I consider it a very important one. But we'll do this again in Calc 1 from scratch with a different perspective. So will you have a problem like this and one like this? Yes. Now the trig values and the inverse trig functions, yes. Finding amplitude, phase shift, and interval to graph. It's too tedious for me to ask you to graph. I'm happy if you determine the amplitude, the phase shift, and the interval in which the function will have one complete period. I'm fine with that. If you want to graph, maybe I'll give extra credit, but I will not ask you to do that. This is a huge topic. Why is it huge? This is algebra. Why is it so huge? For calculus, we need to know what a function composition means and how to decompose, at least mentally, maybe not writing it, but at least mentally because of the chain rule. In Calc 1 rule. Okay, so that's why this is a huge topic. Trig identities, yes, you'll get one. Something straightforward, no 3 pages to write down, just 2 lines or 3 lines at the most. Applying the trig functions, finding, using the identities, sine alpha plus beta, sine alpha minus beta, double angle and half angle. So you will have something like this. Solving a triangle, yes, it's very important, huge topic, using the law of sines, law of cosines. Parabola, ellipses, and hyperbolas are very important, but not for Calc 1. They're important for Calc 2. So I don't consider this huge, but you will have a problem like this. Okay? Sequences and sums and series and geometric series, huge, very important, but for Calc 2. Sorry about that. I forgot to turn off my phone. Okay, so huge, super important for Calc 2. The binomial theorem, very important, not for Calc 1, not for Calc 2 per se. It's for your understanding of powers of a binomial, what happens and how many terms. And I would not consider it a huge topic. It's an important topic. We should be able to use it for Calc 1 and Calc 2, but I don't consider it huge. Okay, so let's start with your questions. Anything you'd like to start with, and then we'll go back here and we'll review today and on Wednesday. We just finished these last week. We can go back to them any moment, but let's look here and let's see what you would like to start with. Eli, Zach, if you have questions, please. If not, we'll choose topics from here. I'm ready. Anyone, please? Any courageous yes, I'm here. Yes, Eli, go ahead.
I'm trying to find the one that I was
Yes.
going to ask about.
Yes, please. In the meantime, does anyone have a question? Anything else before Eli finds his question? And it can be from here, of course.
Can we go over difference quotient?
Yes, the difference quotient. Do you want to pick a function? I highly recommend a rational function. because that's really the top. So this, if we understand the difference quotient, I'm not kidding. At least 60% of Calc 1, you know. Okay? Because something else is added in front of the difference quotient and we determine a function that you will see later on. So this is huge. If you understand how to determine the difference quotient, you have about 60% under your belt already in Calc 1. So anyone would like to choose a rational function? Any rational function? Anything? Anyone, please? Okay, I will. Good. So can anyone dictate the difference quotient? The formula, first of all. Anyone, please? If you don't remember, just let me know and we'll continue. I don't want to waste time. Or if you're looking it up, that's fine too. I'll wait. Anyone ready to help, please? Wes, Kevin, anyone? Isaac? Anyone? Does anyone remember the difference quotient?
Isn't it f of x plus h minus f of x over h?
Brilliant, of course, thank you. Good. Can anyone dictate this portion? This one. And I'll do the easy one. Can anyone dictate this?
Would it be 2x plus h
If you say that, then you have to say something else.
plus 1?
Something is missing. You're correct, but something is missing. You said 2x plus h plus 1. What is missing?
Oh, the parentheses?
Excellent, excellent. Perfect. And the denominator, now I know you're going to say the same thing. Awesome. Good. So now I recommend, you don't have to do it in one step, but you have to rewrite it without parentheses. So 2x plus 2h plus 1 divided by 3x plus 3h minus 4, 2x plus 1 over 3x minus 4 divided by h. Anyone remembers the next step, please? We lost Kevin. He's back. Okay. Can anyone tell us what is the next step? Please help.
Would we make the denominator and the numerator the same? Wouldn't we just multiply 3x minus 4 to the left side?
So you mean finding the least common denominator? Correct.
Yeah.
Correct. Perfect. What is it? Can anyone give us the least common denominator here? Can anyone give us the least common denominator? Anyone, please. The LCD, please.
This is probably wrong, but would it be 3x plus 3h minus 4 times 3x minus
Excellent. Thank you very much. They have nothing in common. the least common denominator must be the product of the two. Awesome. Great job. Excellent. So you already told me that you will multiply the numerator here by 3x minus 4. Perfect. And then therefore, what do I need to multiply this numerator by?
Three x plus 3h
Of
minus.
Yes, 3x plus 3h minus 4. Excellent. So now let's see what we get. Careful. We have to distribute 3x to these three terms. Do not write them side by side because the danger is that you may be tempted to simplify in a sum, and that would be a tragedy. So 3x distribute to these three terms, and then negative 4 distribute to these three terms. 2x distribute to these three terms, but with minus in front. And then 1 distribute to these three terms with minus in front. As you know, always watch me run out of room. I always do with these functions. So sorry about that. Okay, so 3x times 2x, 6x squared. 3x times 2h, 3xh. 3x times 1, 3x. Negative 4 times 2x, negative 8x. Negative 4 times 2h, negative 8h. Negative 4 times 1, negative 4. I already ran out of room, right? So I'm going to write underneath. You should not do that, but I have no choice. Okay, so 2x times 3x with minus in front, minus 6x squared. 2x times 3h, 6xh with minus in front, minus 6xh. 2x times negative 4, negative 8x with minus in front. Now I distribute negative 1 to these three terms. Easy. Negative 3x, negative 3h, and plus 4. All this should be here. Right here. But obviously, I ran out of room. I always do. Okay, now anyone remembers what has to happen next? I don't care how it looks, but what has to happen for sure? Anyone remembers those two very important steps? What has to happen now? Otherwise, I have an error and I have to start from scratch.
Everything without an h has to go away.
At least. Excellent. Good. So negative 6, who was that? Was it Blake? Who was that?
It was Isaac.
Yes, Isaac. Thank you so much. Negative 6x squared with positive 6x squared. Gone. Negative 4 with positive 4. Gone. Negative 3x with positive 3x. Negative 8x with positive 8x. Anything else? No. Okay, so let's see what is left. We find our mistakes very easily. Of course, you know that this is over 1 and I have to flip it. So h, 3x minus 4, 3x plus 3h minus 4. Okay. So all terms without h are gone. Yes. So I have left this, I have left this, and I have left this, and I have left this. So 3xh minus 6xh, negative 3xh. Negative 8h minus 3h, negative 11h. Any questions so far? What has to happen next? I'm just, for 1 second, I just want to check my calculations. I have not calculated, we just made it up. So that's 6, that's, ha 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 ha. Got it. So 3x, so 6 and 6 and 3x. It did not look right. I should have not had the negative 3xh. So these two should go away as well. And here's why. So again, 3x times 2x is 6x squared. This times this is positive 6xh. And this is correct. This is correct. This is correct. This is correct. Now I'm checking everything. Minus 6x squared. Yes. Minus 6xh, correct. Plus 8x, correct. Minus minus plus, correct. So these two are gone. Finally, what has to happen? Next, what is the second step? For sure. Otherwise, we know there is an error. What has to happen next? Anyone remembers? What do we do next here? Anyone, please? Anyone would like to help, please? What is the next step?
Get rid of the h.
Yes, of course. And this is it. That's final. So these two steps have to happen. Step number one, all terms without age must go away. If you get something out of the ordinary, go back and check. And then the second step is h has to go away. Good. So this was done. Good. Eli, did you find your question? Do you want us to go back to it, or?
I couldn't find the exact problem that I was gonna ask about, so
Would you give me an idea about the problem? What does it say, or what do we need to do?
it had to do with identities, but there's tons of different types.
Um, So you're talking about the identity that you had on the test?
Sure, I guess, yeah. Identities are probably the weakest thing I can do.
So the identity on the test, let me find it. Is that one with a 1 plus sine x, sine theta over 1 minus sine theta? Is this the one?
Something like that? I don't remember. It was something like that, yeah.